Hello and welcome to the Telcos Get Technical podcast from VMware. In this podcast, we interview various telco specialists, strategists, and industry influencers on how 5G technology is transforming telecommunications. So join us as we discuss the latest developments affecting telco professionals and share actionable tips and resources. Hello and welcome everyone to the Telcos Get Technical podcast here at VMware. I'm your host Anupama Mahabhashyam, Senior Technical Product Marketing Manager. With me, I have my co-host Stephen Hoenisch, Senior Technical Marketing Manager. Today we are going to have a conversation about sustainability with our esteemed guest, Colleen Josephson, a research scientist with VMware Office of the CTO.
Hey, Colleen, glad to have you today. How are you doing?
Doing pretty well.
Great. We usually start off with giving the audience a bit of background on the guest, so you can tell us about your role at VMware and also about some of your history in tech and some of your other roles as well.
Great. Happy. So thank you very much for having me. My background is doing research in low power wireless communication and sensing. But since coming to VMware, I've been more and more involved in sustainable computing. In addition to my research activities in that area, I also have a couple leadership roles in industry alliances. I serve as a co-chair for the Green G Working Group and a chair of the Social and Economic Needs Working Group within the Next G Alliance. And I also represent VMware in the Green Software Foundation.
So Colleen, before we get into some of the technical questions, can you set the stage for us today? Why is environmental sustainability a pressing issue for telecoms? Perhaps even more pressing than some of them care to admit.
It's a great question. So we're used to thinking about the environmental impact of our cars and our appliances, but until recently, many of us, even in the industry, didn't think much about the impact of our technology. One statistic that might surprise you is that right now, the whole ICT, that's information and communication technology industry, has a carbon footprint that's roughly equivalent to that of the aviation industry. So while we're not the quote unquote worst offenders at the moment, we need to think about our trajectory. There are some recent studies that state that without substantial action, we're on track for our footprint to be quadrupling in the next decade. And this is largely because of the expected increase in demand. Every generation of technology sets new standards for high speeds, low latencies, ultra reliability. Furthermore, we also have the explosion in smart manufacturing and IoT. So the number of devices on our networks is growing exponentially. Though that means that the challenge going forward will be, how can we satisfy these performance expectations without increasing our footprint?
Colleen, so I have read the paper that you and several co-authors recently published. The sky is not the limit, untapped opportunities for green computing. In that paper, you mentioned 4 key pillars. Can you please tell us about them?
Sure. The key pillars for zero carbon computing are as follows. First is prioritizing renewable energy. Second is using resources like power and water more efficiently. The third pillar is removing institutional barriers. And the fourth is addressing embodied carbon.
What's embodied carbon? What does that even mean? And what does it have to do with sustainable wireless systems?
Embodied carbon is the carbon footprint that's built into the hardware that we use. So we're used to thinking about the energy usage of our devices, and generating that energy, of course, it can have a carbon footprint. But the process of creating and transporting our hardware also has a footprint. The steps used to manufacture semiconductors, for example, can have significant emissions. And then those semiconductors need to be transported, which usually burns diesel fuel. In fact, for many organizations, this embodied carbon is the biggest portion of their footprint. I've talked to a number of operators where reducing embodied carbon is one of their highest sustainability priorities. And this is important for the rest of the ecosystem because those operators are incentivized to buy products from their most sustainable suppliers.
That's a really interesting answer. So it kind of raises the question, at least for me, of how can we as telecom operators and application developers make sure that the energy we consume is from renewable and sustainable sources?
Yeah, so right now, the majority of the electricity we use is generated from non-renewable sources like natural gas or coal. And as quickly as possible, we need to transition to generating electricity from renewable sources. Some providers and data centers have looked towards on-site generation, so investing in their own solar panels or wind and other sources like that. Others have looked towards renewable energy agreements with their power providers, where they buy up the renewable share of the energy that is generated by the provider. And this approach has the added benefit that it can help put economic pressure on the utilities to generate more renewable energy, as people buying up the renewable portion shows that there's demand from the users. So what we can do in the meantime, while we're waiting for this like systemic change in our power, where our power comes from, we can take steps to keep the footprint of the power that we use small in the meantime.
I understand what you're saying, but what is the key to minimizing the energy consumption and carbon emissions of computing?
So driving towards efficiency is something that most of us already aim for. Intuitively, using fewer resources to do the same work saves money, which is good for any business. VMware's core technology of virtualization is actually a fantastic example of using resources more efficiently. Before server virtualization, the average server utilization was only about 5 to 15% because each application ran on its own machine. And for the most part, those applications were not busy much of the time. Then with server consolidation due to virtualization, where you're allowed to run many virtual servers on one physical machine, this has led to server utilization rising, but in many cases, it still remains beneath 30% for several reasons, which I'll go into a little bit. One of them is having oversized virtual machines and zombies that are unproductively hoarding and stranding resources. So they're sitting there and doing nothing and keeping the useful machines from doing things because they're using up the resources. We also, second of all, tend to see a lot of significant and unused spare capacity, and this can have a number of causes. So we often over allocate for peak demand because we don't want to crash if something goes viral. Or another common thing is not being thoughtful when we run routine jobs. So think about, do your internal backups happen off peak, or are they competing for resources during your busiest business hours? And then finally, number 3, the fundamental design of the application is often to blame. Today's developers have grown up in an age of plenty and aren't necessarily used to designing applications to be as efficient as possible in their uses of resources like compute, storage, or networking.
That's really interesting. So sometimes when I'm thinking about managing, I think about orchestrating workloads to move them around and how you can do that more easily. Is there a way that you can use, say, time and space shifting of computational workloads to match renewable energy production and significantly reduce fossil fuel use for telcos? Is that something that's conceivable?
Yeah, that's something that we're working on investigating right now. So the carbon footprint of the energy that we use is actually not fixed in time. And that's because the sources that we use to generate our energy, they can be a mixture of carbon emitting things like coal and natural gas, as well as renewables like solar and wind. But as we all know, we have no control over when the sun shines or how much the wind blows. So we see all sorts of variation in the carbon footprint of our electricity. And this varies over the course of the day. So for example, during daytime, we can harvest solar energy, but we can't do that at night. And also seasonally, depending on where the data centers are located, for example, equatorial regions have a very consistent amount of sunshine because the days are 12 hours. But if you move very far north or south, then you have seasonal variation in how long the days are. So we can leverage these seasonal and daily patterns to move when we do the computation to locations or times of day that have more renewable energy available. So one example is shifting things in time. So if you have a routine batch job, you can look at historically when the emissions in your local power grid tend to be the lowest. So maybe it's, first thing in the morning, right when solar power becomes available, and maybe you're not too many people are at work yet, and you can run your routine jobs kind of in that nice peak time where you're not competing for resources, but also the energy is the most renewable.
That's really interesting line of work, Colleen. Can you please tell us what else is happening at the innovation in sustainable computing?
Well, there's another VMware project called Deep Cooling that's top of mind right now. Data center cooling consumes a lot of water and power. In fact, some municipalities, especially those in desert regions, are actually starting to prohibit new data center developments over concerns about their water use. So we've teamed up with Intel and the Chinese startup Quark Data to use AI, artificial intelligence, to optimize data center cooling. Deep cooling models various physical systems such as power load, heating, and cooling of the whole data center by using historical data, and then optimizes the control of the cooling system based off of the prediction of the loads. Well, deep learning-driven optimizations of data center cooling have been done before by players like Google and their own proprietary data centers. Deep cooling is the first, to my knowledge, designed to work in arbitrary data centers. There's a blog post being drafted about this work right now, actually, so listeners should check out the VMware Octo blog in the coming weeks to learn more details. In addition to deep cooling, the Green Software Foundation has been doing a lot of really great work in open source tooling and standards to quantify the carbon intensity of software. The Green Software Foundation, for those of us who might not have heard of it, it's a not-for-profit open to companies, universities, and also individual contributors. VMware joined a couple of years ago, and we found the GSF, Green Software Foundation, to be a really great way to join forces with the other major players and to share ideas and progress the field of sustainable computing. Sometimes, making progress and overcoming kind of some of this activation energy can be easier when you have people to, in the greater community to help progress things.
So how can we at VMware help overcome resistance to implementing computing strategies and practices that reduce energy consumption, carbon emissions?
Yeah, so that gets to the last pillar that I was talking about organizational and institutional barriers. So sometimes an organization's policies can make it hard to progress sustainability. So for example, one common challenge I hear about for engineers is that the incentive structure at their company is designed to reward new features, and they'll get no recognition for doing incredibly important work like redesigning an existing feature to be more efficient. And these soft barriers can be very detrimental to progress. So to sum things up, it's important that we try to push the needle in all the pillars, prioritizing renewable energy, using resources more efficiently, removing institutional barriers, and addressing embodied carbon. And I think VMware has been really active in pushing these forward, and I'm excited to see where we go next.
Thank you very much, Colleen, as always. And thank you, Steve. Thanks to our listeners. And so we invite you to come and visit us at MWC Barcelona in our VMware booth at 3M11. It's 3M11 to check out our latest sustainability innovations for telcos. We'll see you again, and take care, everyone.
Thank you, Anupama.
Yeah, thank you very
Colleen.
much.